This is the fourth lab TCP. First, we are doing first part capturing a bulk TCP transfer from your computer to a remote server. For this, we have to open the browser and we have to enter this link in another browser. And we have to save this in our file folder. This is the folder. You have to save this. After saving, you have to upload it in this link. Here in choose file, you have to choose our file and ready to upload. Here it was chosen. But before uploading, you have to go to Wireshark and start the packet capturing. Then upload it. After successfully uploaded, then you have to off the packet capturing. We will answer the questions. The questions are in second part. Second part name is a first look at the captured address. First question was what is the IP address and TCP port number used by the client computer that is transferring the file to gaia.cs.umash.edu. For this we have to go to Wireshark. First of all we have to search here HTTP. Here it is. Its IP address is 128.119.245.12 and TCP port number used by the client computer. Its TCP port number is 60740. And the second question, what is the IP address of gaia.cs.umash.edu and what port number is it sending and receiving TCP segments for this connection? Its IP address is 172.16.56.99 and its TCP port number is 80 and TCP port number 80. It is sending and receiving TCP segments for this connection. And the third question, we have to answer this third question only if we have created our own trace, because if it is not working in our laptops or PCs, we will use there is already created file here. We will download this file and from this we have to extract the file this TCP ethereal trace one. If we are using the Wireshark by using this, then we no need to answer this third question. But if we do it on our own, then we can answer this question. What is the API design? TCP port number used by your client computer to transfer the file. Our client computer use client computer use 128.1.9.245.12. It is the IP address it is used, and the source port also same 60740. It is same as question number 1. We are answering questions of the third part. TCP basic. What is the sequence number of the TCP SYN segment that is used to initiate the TCP connection between client computer and the given server? What is in the segment that identifies segment as a SYN segment? Here for this, first of all, we have to locate SYN file. First SYN file, then SYN ACK file, then ACK file. These three are in the count straight. First of all, we have located SYN file. Then we have answer. What is the sequence number of the TCP SYN segment? TCP SYN segment sequence number is this is 24457204030. And what is it in the segment that identifies the segment as a SYN segment? In SYN segment, you will see the SYN flag is set so that it is identified as SYN segment. What is the sequence number of SYN plus ACK segment sent by the server to the client computer in the reply to the SYN? What is the value of the acknowledgement field in the SYN ACK segment? SYN ACK segment sequence number is 120213225. What is the value of the acknowledgement field? Acknowledgement field value is 24457204031. How did determine that value? And what it is the segment that identifies the segment as SYN ACK segment. In SYN ACK segment, see here, SYN is set and acknowledgement is also set. SYN plus ACK equals to SYN ACK segment is both flags are set, so it is identified as SYN ACK segment. Sequence number of TCP segment containing HTTP post command. Here in TCP segment, since in this files packets, you can see here that your post it contains complete data about the file we have opened. How to search for that? Like this, it will show complete about post and complete data here. Then we can answer that questions. We are going to answer the questions for eighth question. Length of each of the first six TCP segments. First TCP segments length 0, 0, 0, 0, 0 0. What is the minimum amount of available buffer space advertised at the receive for the entire trace? Available buffer space was, it is the window size. Buffer space means calculated window size is 6780. Does the lack of the receiver buffer space ever throttle the sender? No, because calculated window size is not less than the length of the segment, so it's not. Are there any retransmitted segments in the trace file? No. What did, what did you check for in order to answer these questions? To answer these questions, we'll check that here sequence is 1. Here it is yes, because here sequence 1, sequence 1, sequence 1, sequence 1. It is not changing, so the answer is yes. How much data does the receiver typically acknowledge in an ACK? In an ACK, data is only 0. Every file has only 0 segment. Can you identify cases where receiver is hacking? Where every other received segment? No. What is the throughput for the TCP connection? Explain how you calculated this value. For calculating throughput, first of all we have to take the length of the first TCP segment, and we have to take the length of the last TCP segment, and we have to subtract it from first TCP segment, last TCP segment length minus first TCP segment length. Then after we will get one value. After that we will again do this with the time. We have to take the length of the last TCP segment of we have to take the time of the last TCP segment and time of the first TCP segment. We have to subtract it, then we'll get value. Now we have two values, its length value and time value. We have to divide it, then we can get the value. That was the throughput of this TCP question, TCP connection. We came to last part of the fourth lab TCP. Question is, use the time sequence graph plotting tool to view the sequence number versus time plot of segments being sent from the client to the server. Can you identify where TCP slow start phase begins and ends, and where congestion avoidance takes over? I already drawn the graph. This was the round trip time for TCP segment. We have to stream 5 and switch direction. Then we can see this plotting of graph. Here round trip time for 49.44.194.137 to 172.16.59.149. These are the IP addresses. Answer each of the two questions above. For trace, you have gathered when you transferred a file from your computer to server. Here also you have to plot one more graph, but here from round trip time for 172.16.59.149 to 104.18.36.252. Here the IP addresses are different. Here you have to stream only 4, and it is a round trip time in meter per seconds. That's it for the fourth lab.